Hi, my name is Ryan St. Clair,
Hi, I'm Keelan Bell.
and we're part of CSSE 220 Team 61, and we are presenting our Joust version.
So I'm going to start by showing some of the functionalities of the program, and I'm going to start with the help screen. So when pressing the help button, you get this message right here, done in the J option pane, that shows how a character moves and how a player would change levels. Clicking the OK button brings you back to the menu. Obviously, clicking the exit button will exit out of the game, and for the sake of the video, I'm not going to click that one, but it does work. And to start the game, you press the start button. So this is the first level. The player moves with arrow keys. When hitting the top of a monster, the monster disappears or is killed and then drops an egg. I pick up the egg almost simultaneously, which is why it's a little bit different. There's the egg. And then if I leave the egg alone for a little bit, it spawns into another monster. Now, the monster movement is done with random number generation, but there are static variables that can be changed that affect the movement of the monsters. And then we're going to move on to the next level, where we have a ranged monster. Now the ranged monster fires bullets, and if I can get one to hit me, we can see that the bullets in fact do kill. And then for the sake of winning, we're going to go to the last level. When you complete the game, this message shows telling you your final score, which in my case is 20 because I killed the one monster. When I changed the levels manually, however, it did reset my score. So ideally, if you're playing this game, you're not supposed to reset the levels manually, but for the sake of the presentation, I just did that so we could get to the last level. And then when you press the OK button right here, it closes the program.
So that was the functionality of our Joust game. To go over the design a little bit, this is our initial UML diagram. As you can see, we have a game viewer that runs the game. We have a game component that dictates the component-wise functionality of the game. Each game component has a sprite. Sprite includes an interface called pickup, which we did not get to, unfortunately. If we were to continue working on this game and perhaps make a second version, we would include power-ups, we would include weapons, but since we only have one egg and that's only one type of pickup object, then we thought that the inheritance or the interface of the pickup would be unnecessary. So for now, egg is a type of pawn. The difference between sprites and pawns, and as you can see, the sprites array list would include an array list of pawns. And the difference between sprites and pawns is that pawns are movable sprites, so they are influenced by gravity. They may or may not move by character control or by random movement. Platforms, for example, is another type of sprite, and platforms do not move. However, they do allow for collision with the player and with other pawns. So as you can see, player is a type of pawn that can be moved, and monster is a type of pawn. There's also monster range and monster boss. However, with our final design, we did not get to the monster boss. Again, if we were to continue working on this, that would be something we would include. Notice with this one also, we have populated it with methods. We do have some differences with our final design. First of all, we have a level loader class, and that just uses file IO to read different levels. As you can see, we have a folder full of 4 levels. You have a type of object that you are putting into the game. You have the X parameter, the Y parameter, the width parameter, and the height parameter. And this goes for platforms, monsters, range monsters, and it can be included if you were doing, pickups, or maybe you have pickups spawn randomly in the game, or you can have them preset in the level, and that would be handled by the level loader. Another difference is that we have two different types of platform. We have the main platform, and then we have the border platform. The border platform prevents horizontal movement, whereas the normal platform prevents vertical movement. We also have pawn, since on monster killing, then the egg will drop. It'll be influenced by gravity, and so it should be a movable type of sprite, otherwise known as a pawn. We also have the bullet class, which is a type of pawn. The bullet moves. The bullet is spawned by ranged monsters, and on collision with the player, it instantly kills the player. So what we can conclude about this design is it has high cohesion. So we believe that it's clear that each class does have its own responsibilities. We even split up the responsibility of a platform to include limited movement of the x-axis with the border and with the platform for the y-axis. We have the sprite versus pawn. So sprite has its own responsibilities, pawn has its, whereas the pawn provides movement to sprites, and sprites provide a more static game object. And the reason why this would be important is if you were theming the project. If you wanted to theme the project, then providing static sprites would allow for adding different level designs, adding different images, icons, whatever you would need. And it wouldn't be influenced by gravity, it wouldn't move, and it can just be in the background theming the level. So this has been our CSSE 220 Joust project. We hope you enjoyed.